Hey guys, welcome back. We are here for lesson 114. So hopefully you watched, I sent a video for 113 that was just something to watch for volume. So it was a review of what you've already learned about volume, but then also introducing the new volume formulas and concepts. So that will apply for lesson 113 and a little bit for 115 too. So I might make an additional, I'm gonna look at 115 again. I might be making an additional video for that one just to kind of tie up a couple of loose ends on that. But the video that I sent you should be sufficient for 113. If you have any questions though, read back through the notes on that in the book too, because it all pretty much lines up. I like that guy that makes those videos. He does a pretty good job. So anyway, we are here to talk about 114 today. And you guys have lessons this week and next week. And that's it. You're done with all your lessons. 120 lessons you will have accomplished. That's a big deal. So I'm really proud of you guys. And especially doing it the whole last term, having to do it at home without coming into class at all. Like, you guys are awesome. So keep it up, okay? You're almost there. You're so close. So today we're going to talk about graphing linear inequalities. This is going to be like basic intro to graphing linear inequalities. Okay. Y'all will talk about this a lot more next year. Most of you are going to be going on to Algebra 1. When you get to Algebra 1, this is going to be one of those concepts that you focus on. And it's going to be a different presentation. Today's presentation of it is just going to be real intro, let's just look at what this looks like and talk about the characteristics, and that's pretty much it. Okay, so just kind of work with me. The point is for you to get like the ideas here of what we're doing. Next year, you'll be doing it a lot more in depth and kind of utilizing it a lot more to show other representations of it. Okay, so just ignore that. You don't really need to know that, but anyway. All right, so let's get started. So we are going to look at graphing a line on the coordinate plane. So we've kind of talked about graphing inequalities on a number line so far. This is going to be graphing them on the coordinate plane. So when we're asked to graph all pairs of numbers x and y whose sum, remember sum is an operation word that tells us add, right? Whose sum is less than 10, and then less than is important because that tells us what our inequality sign is going to be, okay? So we want to pay attention to those words. Now, that means that we are writing the equation, which I already have up there, but it should be x plus y is less than 10. If I hadn't given it to you, you could have used your context clues that we just talked about to get there. So now what I'm doing on the graph is I'm just saying, okay, what x and y values can add up to give me 10? Well, I know that 2 plus 8 is 10, so I could go like this. I could go, well, 2 and 8 is 10, so that's going to make a point right there. Then I could go, well, 4 plus 6 is 10, so that makes a point right there. 6 plus 4 is 10. 8 plus 2 is 10. Now notice that all of those little dots that I just made, if I were to connect them, form a straight line. So the first step here is to form your line. Then, and we're going to look at them, I've written these 3 steps down on the next slide, so you don't have to write these down yet, but first step is to graph the line using what you know. The second step is to figure out which side you need to shade, okay? Because this says x plus y, our inequality says x plus y is less than 10. So that means that we're not just talking about where x and y equals 10. That's what the line represents. The line itself represents where x plus y equals 10. But we're not given an equation. We're not given an equation here. We're given an inequality. And so an inequality tells us that we need to shade one of these two sides of that line. So either we need to shade up here on top, or we need to shade down here on the bottom. So now our goal is to figure out which one of those is correct. And the way that we do that is we pick a point on each side. So I'm going to just keep it simple and go with 4, 4, which is what this point would be, and 10, 4, which is what this point would be. Now, the way that you test them out is you just plug them in. Remember, the first coordinate, the first value in a coordinate is always the x value, then the y value. They always go in alphabetical order, x then y, x then y, okay? So let's try the first point. So we are going to, here, let me do a little labeling to help you out. So this is point 1, okay? So let's start with point 1. So for point 1, we are going to plug in 4 for x and 4 for y and see if we get a true statement. So 4 plus 4 is 8, and we know that 8 is in fact less than 10. So that is a true statement. So now, if that is a true statement, then we would expect that this point on the other side of the line would not be a true statement, okay? Because notice this point, the green point, is on the left side of the line or kind of the underside of the line, and the red point is on the outside of the line or kind of on the right side or the upper side if you want to think about it that way, okay? So let's test out the red point. So that one was 10 for the x and 4 for the y. So if I add and simplify that, 10 plus 4 equals 14. Is 14 less than 10? It is not. So that one does not work. So that tells us that if the green one was the one that fits, then we shade where that point is. We shade the side of the line where that point is. Okay, there's one more piece to this puzzle, one more step, and that is that we need to figure out if this line that we drew initially is actually solid or dotted. Now this is there's a really easy way to figure this out, okay? If the sign, the inequality sign, has a line underneath it, so if it looks like this or like this, then it's gonna be a solid line. Okay, because that line underneath it tells us that it equals that line too, okay? But if our sign looks like this or like this, it's gonna be a dotted line, because what that means is that it's all these points in here that are less than 10, but it's not equal to 10. So what we could do is we could just take our eraser and just make all these little dots on our line, basically, so that then it becomes a dotted line. It's not super great, but you kind of get the idea. Okay, all right, so let's look at, those are the three main things. Let's look at the list version of those so that you guys can see. So if we flip on over, there we go. So you want to plot your line, step number 1, which is what we did. We found those points, right, connected. Step number 2, you figure out your shading. How do we do that? You use 2 test points. Your test points must be on opposite sides of the line. Okay, sides of the line. Okay, and then you figure out if it's dotted or solid. So remember, that comes from this whole thing. And actually, I'll go ahead and show you guys my fun little tools for this. You're gonna like this. Okay, so I think I might have showed you all this before, actually. Probably did. So you'll probably remember. But we've got a robot and a snowman. So the robot looks like this, and the snowman looks like this. So now this is just to help you remember that when your inequality signs have these lines underneath them, like this, like the robot, then your line is going to be solid, just like his smile is. Or it's actually not a smile, but you get it. Robots don't really smile. So it's going to be just like his mouth, solid, okay? If your inequality signs look like the eyes of the snowman and do not have the little line underneath, then your line is going to look like the mouth of the snowman, dotted. See, simple. Robot and snowman. Let's just label them. Robot, snowman. You guys should work on coming up with some good names for them. They need names. So I was just call them the robot and the snowman. Y'all work on that and get back to me. Okay, so let's move on. So let's look at one more example. Every day, Angela runs and or walks for 15 to 20 minutes. Write two inequalities for Angela's running and walking time and graph the region that satisfies both. Notice in this one, I did not give you equations or inequalities. So you have to make them in this one, okay? So she runs and or walks. First, it's important to identify what our variables are. She's running, we don't know how much time she spends running, so we'll call, running, so we'll call that X. We don't know how much time she spends walking, so we'll call that Y, okay? So we've identified what X and Y stand for. Now we know that she's gonna do that for 15 to 20 minutes. So that means the least amount of time she's going to spend is 15 minutes. The most amount of time she's going to spend is 20 minutes, okay? So let's think about how we could write that in inequality form. We're combining the time that she spends walking and running. So that would be addition, right? And it has to be more than 15 minutes because that's the least amount she'll spend. So it has to be more. Could it be 15? It could. It says for 15 to 20 minutes. So it could include 15. So we're going to say X plus Y has to be greater than or equal to 15. Okay, so hopefully you guys see how I came up with that just from what we read. And then X plus Y also could go up to 20 minutes, but it can't be more. So it has to be less than, or it could be equal to 20 minutes. So these are our two inequalities here, okay? So we would graph them separately. So let's start with the top one. In the top one, we know X and Y have to add up to give us 15. So 15 and 0 would work. 5 and 10 would work. 10 and 5 would work. So just like we did before, we can connect those dots, and that's going to give us a nice little line. I don't really like that one. Let's try that one more time. There we go, much better. Okay, so then we could do the other one. So X plus Y equals 20. So we know 0 plus 20 would work. Then 5 plus 15 would work. 10 plus 10 would work. 15 plus 5 would work. So here is our line for that second equation. Oh, sorry, guys. This is not the easiest tool, even with my awesome Apple Pencil, not the easiest tool in the world to use. Okay, we're gonna go with that. That's close enough. Okay, so now we've got our lines on there, even with two of them, which is a little different, but we got two of them, so we got our lines on there. Now we need to shade. So remember, we figure out our shading using test points. All right, so we need to use test points. So we are going to, and if you'll notice, this time with two lines, we actually have three possible places that we could shade. We could shade over here. We could shade inside of here, which let's just go with like this one. Or we could shade out here, okay? Because it could look like this, shading right here, or it could look like this, shading in the middle, or it could look like this, shading out here. So that's why I've put a point in each of those regions, okay? So we can test. So the coordinates of this point right here are 5, 5. The coordinates of this point right here, I'm gonna estimate, we're gonna say 15, 2. That's about right. And then this point right here is gonna be 20 and 5, okay? So let's plug those in one by one and see which one is true. Now, it has to be true for both, okay? So we're not just plugging it into one this time, we're plugging it into two inequalities and looking for truth. My daughter did my nails earlier. Can y'all tell? No? Yep, okay. All right, so we've got 5 plus 5 is greater than or equal to 15. So 5 plus 5 is 10. So is 10 greater than or equal to 15? No. So you know what? We don't even have to do that one again because that automatically rules that one out. So that one is a no-go. Let's use red. That one is a no-go, okay? So now let's try the next one. So let's try the 15 and 2. Okay, so 15 plus 2 is greater than or equal to 15. So 15 plus 2 is 17. 17 is greater than or equal to 15. So that one works, but we got to make sure it works on the other one. So let's see if 15 plus 2 is less than or equal to 20. 15 plus 2 is 17, and that is, in fact, less than or equal to 20. So that one works too. So this one is going to be our winner. We could go ahead and plug this one in. If you want to try that one, you can. But since we found the one that works, I'm just going to go with it so that way I don't make this video any longer than it already is because we're already getting pretty long. So that would be our region. That would be our answer. Only other thing we have to do, dotted or solid, all you do, remember, robot, snowman, look at your signs. Those are both robot eyes. So we've got straight lines, people. All right, well, that's it. Just remember 3 main things here. You've got to graph your line. Then you've got to find out your shading using test points. Then you've got to determine robot or snowman. Are they dotted or solid? You guys are good to go. Happy homework.